Hi, I'm Jeremy Malczyk, a cloud geographer here at Google. I've been geography obsessed from birth, spent my formative years on a bicycle making maps of the wilderness in suburban Connecticut, probably at way too young an age. These days, if you were riding around 20 miles from home at age 9, you might find a visit from the authorities when you came home. Anyway, so I help governments and businesses figure out how to do these kinds of things for themselves in the cloud with the help of tools that we build here at Google in the ever-expanding universe of open source. Today we're kind of riding in a golden age of geospatial and AI, and there's a saying, in a gold rush, sell shovels, and so we have some really big shovels here that we'd like to show you and maybe incorporate into the work you're doing. But let's go back to where it all started and kind of where my own trajectory in this space really started to incubate. Remember this thing? Yeah, so I was in Seattle working in a tiny startup. Walked in one day and the other 5 people were huddled around a computer just dragging this thing back and forth. Like, there was no pan to the right, pan up and down. I didn't have to wait for the screen to reload. It was just like magic. I was like, really? That's what's going to change the world, right? So I went back to work on my University of Minnesota map server ASP pages, trying to do real important things, and Google Maps started to change the world underneath me. So fast forward to a few years later, and I'm in my backyard, on the porch of my grandparents' house, explaining to them how they got this picture in Google of my dog sunning himself in the backyard, and my wife was there too. And they asked me, like, how'd they do that? And then this thing drove by, like, on cue, like that moment. So tell me we're not living in a simulation. So today, last night, coming up from Penn Station, I was using Google Maps to get me through this world. You know, it's now like, it's really kind of controlling my universe now. Navigating me to the hotel that had sold my room to somebody else. So that was the beginning of a long night, and got back to my new hotel down in Times Square to use Google Maps to tell me how much more time I was going to use in the morning to get here, and how much time I was going to not have to finish these slides. But yeah, this is a big deal. There's over 250 million businesses and places in this database now. It's growing bigger and bigger. We're now pulling in air quality measurements on our Street View cameras, 2 billion air quality measurements across 230 million locations, and then 1 billion people use these services every month. It's like the map of the world, and which is what we actually called it from the beginning at Google, and it's really become that. And now you can build these things yourself. You can build on top of it. Cardo's done it. Many of our partners have done some amazing things on it. You can use these new 3D tools that we've launched in the last year or so. So open source, the OGC standard, photorealistic 3D map tiles. New York Times has done some really amazing work in the last year on the Lahaina wildfires. If you haven't seen it, last fall that came out using that product. We have aerial views that you can make like pre-recorded things, or build these really immersive experiences, or just put a Slippy map and your data on top of it. So we make that all available to you. And now one of our latest launches is being able to do that 3D mapping right there in the JavaScript API. And it's gotten so much simpler that you can just kind of put a tag in an HTML page. I don't know how many web developers there are here, but skipping a whole bunch of JavaScript to put a very immersive map like this is pretty great. So those are your tools for visualizing and exploring the world and getting out there and finding your long-lost dog in your backyard. But we're here to talk about analysis. So our tools to store and analyze planet-scale spatial data, that's where we really differentiate. That's where Google brings some really cool shovels to the table. And our platform looks kind of like this, our geospatial portfolio. On the left side, we have our data warehouses for spatial data, Earth Engine and BigQuery, which y'all have heard quite a bit about, Vertex AI for plumbing AI into those tools, and the visualization tools that Maps brings us. We're going to talk really briefly about BigQuery because I think most of you know what it is. What's going on here? This slide. Not sure what happened to that slide. There's no video or anything there. Anyway, so BigQuery is our tabular data warehouse. It's just sort of a the database as a service that you don't have to think about scale. It is fully managed. It is scalable across tables of unlimited size, really, and so you don't really have to think about managing data and how you access it. In the last year, we've been finding that 66% of customer data is dark data, often unstructured and unmanaged, difficult to analyze and govern. So with Gen AI, we've been kind of unlocking some opportunities to get at this data. And lately we've introduced a multimodal data foundation that seamlessly combines structured and unstructured data, including PDFs, docs, images, and things like that, unlocking the potential of that data to generate new insights. And we're witnessing a remarkable 600% growth year over year in unstructured data under management. So BigQuery makes it possible to branch out to this unstructured data in places that are outside of the data store, like we're seeing with some of the geospatial open cloud-native formats. So this multimodal foundation supports single copy architecture, ensuring efficiency and consistency, spanning managed storage, Google Cloud Storage, as well as data residing in, like I said, in other clouds, such as AWS's S3 and Azure Storage. And we're enhancing our open format support for seamless interoperability with Iceberg, Delta Lake, Hudi, and offering a fully managed experience with performance acceleration. So, and unified data access and control from a single interface that further simplifies data management and governance. So this is really just like an enterprise-grade way of managing data. This is not news to this crowd, but these are some of the new features that we're seeing come out of BigQuery. But this is a spatial conference, and that's what you care about. So several years ago, Chad Jennings, my colleague at Google, first launched BigQuery Geospatial right here at this podium. I'm pretty blown away that I'm standing in the place that Chad did that. That support's only grown since then to include new functions, AI capabilities, integrations to expand BigQuery's reach beyond what it was, capabilities that Javi has been talking about in his talk that Cardo's leveraged to create even more value on top of it. And now, it had already supported those open formats, but he mentioned, and now supports read and write to GeoParquet. Pretty big deal, right? 2 years in the making, and it's there now for you to exploit. Please do it, and I can't wait to see what you're able to do with that. So that's BigQuery. On to Earth Engine, our next big shovel. These are the big shovels, these two. Earth Engine is a product that's very near and dear to me. I started using it well over a decade ago with CartoDB at the time to do biodiversity mapping when I was working at Yale on the Map of Life project. So what's Earth Engine? It's three main components: a data catalog, huge data catalog, 90+ petabytes of data. This computation platform that's co-located with it and gives you a way to deploy algorithms over it, and then this ecosystem of apps and users that collaborate to create even more value on top of it. That's really something that shouldn't be understated. You can, as commercial users, as other academic users, you can leverage what other people have done quite easily on Earth Engine. And it unlocks a wide range of customer use cases. So things in sustainable sourcing, we've had a lot of traction. Agriculture is a huge one. There's, when you can monitor agriculture agriculture is quite easy to monitor from the sky. Basically looking at greenness, and as long as you have a good frequent update, and the satellites that we ingest in Earth Engine are quite suitable to that. Protecting natural resources. One of my customers is the Forest Service that monitors changing forest conditions for wildfire, things like that, environmental impacts, all kinds of things that anything you can really get from overhead imagery, Earth Engine is appropriate for. And we keep adding new data. So there's over 100 new data sets in the last year. Grows at like a petabyte a month. Like, it's just an absurd amount of data at your fingertips. We now have commercial data in our GCP marketplace that you can leverage in Earth Engine. So this is PlanetScope data, their marquee product that you can use for your workflows. This is high resolution, high revisit rate, really gets beyond that 10-meter resolution weekly revisit that we are used to with Sentinel-2 for the public catalogs in Earth Engine to something that's finer grained, and you can start to see objects and things like that. And the last year, we've really focused on the ease of use, reliability, and transparency of Earth Engine for Python. One of the knocks on Earth Engine over the years has been, oh, it's just for JavaScript, right? But it's not. It was originally, that's the development environment that people are used to, is this JavaScript development environment. But we've been really pushing the Python ecosystem hard the last 2 years, and it has grown around us. What's been great about, and the reason why we did it, was because we saw these tools in the Python data science ecosystem developing, and we needed to give access to Earth Engine to those users and those tools, and that ecosystem is really blown up. We have visualization tools from GEMap, ways to serve Xarray formats. Like, it's really limitless possibilities to how you can incorporate Earth Engine with Python. For Carto, we have improved our batch zonal statistics performance significantly, and that continues to get better. We're monitoring this daily and adding refinements to bring that time down. So zonal stats, what we call reduced regions in Earth Engine, has historically been kind of slow. It wasn't really built for performance in that regard, and we've made some major changes that have really sped it up. So these are the kind of things that will really be reflected in workflows that you're launching from Carto or directly in the platform by orders of magnitude. Task management has improved. So these are long-running batch processes that you can launch in Earth Engine. Earth Engine has two different kinds of ways of talking to it, like give me an answer right away, maybe don't use as many resources and do it quickly, or run this thing using more resources for up to a week. But the control and transparency of like how those processes were running has historically been a bit tricky. We've increased that. Commercial users can get more concurrency, more tasks working, so you get additional buses to move your geospatial workloads around, which can make a big difference if you're trying to do something very big. And controls to prioritize those. So if you launch something and you want to maybe deprioritize it, you can do that now. So this is available to commercial customers now. Task management, we've incorporated this into our cloud console. So there's been just a lot of GCP direct integration. So Earth Engine has historically been its own separate service, and we've been kind of moving it into the cloud over the last few years. And then just more support for integrations with BigQuery. You've been able to push it out to BigQuery for a year now. You're going to be able to read from BigQuery in the next later this year. Support for other cloud-optimized formats. Cloud-optimized GeoTIFF has been supported for a while now, but we're expanding that to be able to reference data sets that are across many. Okay. We also have tools to build and deploy AI at scale. This is important with Earth Engine and BigQuery because this is how you really like extract value from those products, right? Earth Engine introduced interoperability with Vertex AI last year to connect to machine learning models that are trained there directly, and talk through cloud storage to pass data between the two. This is really important for really refining your models to get more value from that remote sensing imagery. Now, tools to find and understand data. This is like a simple, difficult thing that we've actually not done a great job over the years to really say, we have this massive data catalog, what's in there that I can actually find and use for my purposes. So we've been experimenting with using LLMs to ingest that catalog and allow you to ask a simple question, how has deforestation in the Amazon rainforest changed over the last 20 years? Get a list of data sets that are appropriate for that, a map to go along with that data set, and then down the right corner there, some thoughts from Gemini about how might you actually use this, and why is it suitable, or why isn't some of these data sets suitable. Our partner community catalog has also incorporated a similar search. Okay, finally, these are what we're really excited to talk about, and I have the least amount of time to talk about. The tools that we're generating tools we're bring to you to generate deep insights faster and better. So in the last 3 or 4 years, we've had 3 major products that have come out, or data sets that have come out to enable you with this. Dynamic World's the first one. That is basically a land cover classification that gets run on the Sentinel-2 imagery, which comes in every week or so, and lets you see changes in land cover across 9 different land use and cover types through time. So this is a map of the Quabbin Reservoir in Massachusetts. You can see the ice out event happening right now, in February through June. You can then use Earth Engine to quantify that and see how those changes are happening on the ground. So these are the kind of things that those Carto tools would easily plumb directly into and allow you to kind of generate those changes with the locations that you care about. CloudScore Plus is a way of pulling clouds out. Clouds are a big pain in remote sensing. If you're not a remote sensing person, most of the imagery is visible, so if there's a cloud in the way, you can't use those pixels. So we developed a way of isolating usable pixels and giving you a way of thresholding how aggressive you want that thing to be to pull those clouds out and generate a cloud-free mosaic. Finally, the thing that I'm really excited about is this embedding fields model. Now, this is an experimental preview for trusted testers. If you're interested in trying it, let me know. But the idea here is that images are not insights on their own, right? Just a picture isn't going to really get you to value. That's why we have to do these classifications like the Dynamic World did. And doing that is difficult. There's, even with Earth Engine, there's a whole lot of corrections and cloud masking, things you have to do to get to that value and generate those insights. So what if we could use AI as a shortcut? What if we can take these millions of Earth observation images, cram them into a foundation model, build this latent understanding of the world, and expose it as a data set that puts that knowledge, that abstract knowledge of everything that those sensors have consumed into Earth Engine as data, and then allow you to use those machine learning algorithms, the simple classification methods, to make a map of anything. So we can start here and avoid all that mess. So this uses the concept of embeddings. If you're not familiar with embeddings, it's a way of compressing many dimensions into one dimension. It's how you search for cats in Google. It's also kind of similar to spatial indexes conceptually, if you're used to that. So you're taking 2 or 3 spatial temporal dimensions and compressing them into one to make an index. It's a little bit like that it's helped me kind of think about it. It's not the same, but it's how machine learning algorithms are able to associate these many dimensional spaces with each other and translate a cat into the word cat into pictures of cats. So the idea here is that we can make a data set that fills space with those for every pixel, and then expose that as data in Earth Engine to make these maps. So you can just put a couple labels, and it's balanced across time. We have it as like an annual data set at that 10-meter pixel level, and with a couple of labels, you can make maps of just about anything. Those were a couple examples there. This one is it running live in and a little demo app that we built to map fire scars in California with I think we do like 2 or 3 different labels here. I'll let it run. This is pretty much the end of my talk, but let's let this run in like 1 minute here. We're good? Okay, cool. So you see what's happening here. We're dropping just some pins on a map, so you don't have to be an expert to run this thing. Obvious fire scar in the Sentinel-2 composite imagery for 22. This is just south, I believe, of Lake Tahoe. I think that's like Kirkwood ski area up in the corner there somewhere. And you can see it's training and running that classifier on the fly. So it's doing that with live feedback. There's all kinds of use cases you could apply this to. This is just a simple mask, but you could do multiple land cover classes. You could really define whatever you want here. So going from what we did there, and no new labels up here, and just seeing how it transfers to a much larger fire scar further north in California, and you can see it performs quite well. So doing this yourself with raw remote sensing data would be painful and require you to know how to work with it to do it well. But with this, we can just do it with a couple of pins on a map and the magic of the cloud and Earth Engine. And that's all I got. Thanks for coming. If you are interested in trying that last thing out, take a snapshot of that QR code there. There's a form it'll lead you to, and we can put you on our trusted tester list. But you should start seeing more of those capabilities roll out in Earth Engine as data over the next year or so. Thank you.